Well, gentlemen, here we are today. I just recently changed out some power wires on an Ameritron ALS 500M. And this is the stock power wire up to all of these butt splices from an Ameritron, directly from Ameritron, which I feel is woefully inadequate. And we're going to use this simple test rig to demonstrate what we're talking about. Over here is we have a 1,000 amp power supply hooked up to about 8,000 cold cranking amps worth of DC batteries and a whole bunch of super caps. There's more than enough energy here to pull off this test. We have our volt probe with volts in. So this is our load cell, basically, this coil of wire. This is our volts in. This is volts out at the 500 amp carbon load pile. We have 2 inches of wire stripped, folded over twice and wrapped around each other in between the claws, so we have adequate amount of surface area at the wire terminals. Now, you and I both agree, all this kind of common, you universally agree, that some ham guys know a lot about radios, but they're horrible at wiring stuff, especially on the DC side. So I'm shooting this video just so people can have some kind of reference to understand why we need to use bigger wire. Okay, this is a clamp fluke ring here on the ground side, and this is in amps, so amps total past the decimal point and then a tenth. These two meters are reading within 1/100th of each other, tenth, 100th. Over here we have our voltmeter on the front of our carbon load pile, which doesn't mean anything really because it's not all that super accurate. This is our amp shunt, which also isn't really meaning anything to us because it's not super accurate, but it's backed up and bolstered by this amp meter. So what we're going to do is we're going to hit this pretty hard. This is Tennessee Wire Industries 600 volt, 105 Celsius degree wire. The wire's ambient temperature at this time is 74.5. The ambient room temperature is 73, 74.5. So there's no heat load on this wire at all. What we're going to do is this was hooked up to a device that was designed to pull 100 amps average and up to 150 amps peak, 200 amps peak. My argument is, and will always be, that the plug that they use, the way they wire it, is not adequate enough, and that this wire is substandard and not safe. It is too small. I agree with the temperature jacket rating, which for our American friends out there, it's 221 degrees Fahrenheit before the jacket becomes what they consider to be unsafe. And what I mean by unsafe is that the jacket at 221 degrees is so soft that the insulation that they put on the wire no longer carries any UL listing or CE rating for heat, rub, or insulation value. You're claiming that at that point the wire will fail and it's considered not safe to use in any kind of conductor format as an insulator. Okay? So there we go. This is the number of the wire that comes off of there is, like I said, Tennessee Wire Company, AWG, 105C, 600 volt. The number is 1230/1015. And this is 10 gauge wire. So 2 pieces of 10 gauge. Now, this is a short piece of wire. In most mobile applications, I think we can all agree that from the battery to the back seat or the trunk of the vehicle is usually about 20 something feet. 10 gauge is not going to be able to carry the amount of current, I don't personally feel, without having significant voltage drop and a whole bunch of current lost from your feed point at the battery to the amplifier. So this represents your battery. This shunt here represents the volts going in and the amps going in at the battery versus what's coming out, and this represents the amplifier. Your volts and your amps at the amplifier. There's a reason I keep saying use bigger wire, bigger connectors, bigger wire. Okay, let's get set up for the test. Okay, gents, here we are. I've got the load pile put back together, and we modified it a little bit. I punched a hole in the back and I put a high flow 120 millimeter fan in it. On the switch, we wired that with Teflon PTFE wire, so we know that's just not going to melt. But this is all put back together. So we're back to where we started yesterday. The whole point behind this test is the argument that I have that the power wire is too small and unsafe to carry the amount of current from your battery underneath the hood back to the Ameritron amplifier, or any amplifier for that matter of fact. We're talking 110 amps on average, and we're talking, 150 to 200 amps peak. But it's commonly accepted that 4 transistors at 25 amps apiece, okay, those are all average numbers. So that's why when you buy a power supply, it's rated with an average number of 100 amps. It can peak much higher than that, but only for a very small, short, compressed amount of time. So, yeah. Now to add some standard to this. This is Tennessee Wire Company, and it's 105 degrees Celsius rated, and this is 10 gauge. So there's 2 strands of 10, 10, 10, 10, 10, okay? This meter represents the volts in, or otherwise at your battery. This amp gauge and this shunt shows the voltage at the battery. So we're going to do the voltage off the battery with here because it's more accurate, because we have the tenths and 100 scale. And then we have our amp draw. Now this shunt isn't really the most accurate thing in the world. It's the best that Chinesium can provide. We're going to run with it. This shows the amperage at the amp. And this shows your voltage. You're within 100th. Our voltmeter over here, we're not going to pay much attention to it. It's not that accurate. And the amp shunt here, we're not going to use that as like a form of measurement. It's backed up and bolstered by this. So a couple things going to happen. These fuse holders are so shitty that they're going to act like a giant resistor, and it wouldn't surprise me if those blow right away. They are currently fused. Both of these are fused at 30 amp. If we have a failure there, we're going to stop, let everything cool off, come back down to room temperature. We're going to cut and bring our wires directly to the plates. Pretty sure those fuse holders are going to fail. Pretty sure. Right now, currently, the wire temperature is 72 degrees. The room is, well, (73 degrees, 72 degrees. So it's at ambient air temperature. Okay, let's have a little bit of fun now. I've been wanting to do this since yesterday. Volts in, volts out, and amps. So let's start twisting the knob on the load pile here. There's 40 amps. There's 80. Oh, blew the fuse. Just like that, at 80 amps. So think of a long modulated carrier at 80 amps. We still have the 14 point, and it made it to 80 amps. That blows my mind. It's unbelievable. And it popped both fuses. 14.6 going in, 0 coming out. Okay, well, let's reset this over here, and we're going to bypass the fuses. 30 amp. 30 amp. Smoked. Okay. Listen to me when I say this. I'm in no way dogging this guy's wiring, because technically this was safe-ish. He was comfortable enough to risk his vehicle and his life to this wiring. Some of this stuff is substandard. Like, for instance, this. Okay, he did solder this, kind of. What do I mean by kind of? Well, that's what I mean by kind of. This just broke. This is a journal splice that was partially soldered here partially soldered here, and then crimped, and then partially soldered here. This wire free floats in this plug. That's what I mean by substandard. That's it. It was a good attempt, but not the greatest execution. So I give him credit for fusing it. That's great. And yeah, you want to put the fuse at the battery. That's also great. I don't know. I'm a proponent of, like, you know, if you got a 100 amp load, put a 200 amp breaker on it, kind of thing. But that's not technically safe. If you have a 100 amp load, put a 150 amp breaker on it. Allow yourself a little bit of headroom. So, in theory, this thing, each transistor inside that amplifier pulls 25 amps. So, technically correct, kinda, sorta. Okay. So I'm getting ahead of myself. I don't need the gloves quite yet. But we are going to take this to failure to where I got smoke pouring off of stuff. Full reset. Fuses have now been bypassed, hardwired directly to the distribution clamps. The wire is at 73 degrees, which is roughly the same room temperature, about 72. So, it's good. We'll turn our fan on our pile. And let's go ahead and bring on about 100 amp load. There's half an amp. There's 30 amps, 40, 60, 70, 80. There's about 105. So if you put 14 volts in this wire, you're going to get 12.5 or less out the other end because the wire is too small. 130 amps. That's about what it'd peak to. And then we'd unkey. You see how they call this voltage sag. Voltage, voltage, voltage sag. We're losing input voltage, but we're losing 2 full volts on the other end because the wire size. Let's put 100 amps back on it. About 130. We'll take it up there. We'll say it pulls about 150 amps peak. The voltage inside the amplifier before the connectors and all the other plugs is dropping down 11 volts with 13 going in. 14 going in. You see how much current was over here? How much current was getting consumed here with only 100 amps here? Scary, okay? And look at our wire temp now. Let's get down here and let's go look at this butt splice. Butt splice is 100 or 94 degrees. 102. Remember, this wire becomes completely unsafe and not usable at 202 degrees Fahrenheit or 221 degrees Fahrenheit. Remember, it's only rated for 103 degrees Celsius. So let's do this again. Let's bring the pile back on. Now we're going to pretend we're Kevin or John or Mike or whatever, and we fire down and we hold a QSO for a good minute. Like, hey man, this is John, blah, 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 checking into the net. I've done a na-na-na. Okay. There's about 100 amps, 120 amps getting consumed. 240 amps over here, 14 volts going in, and 11 dropping on this end. And let's back this down so we stay around 100, 150. All right, Kevin and John and Mark and Ron and the rest of the Good Time Harry gang, back to you into the net. Blah, 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 blah. And that's in the mobile now. Now we unkey. That was just with a couple second key. That butt splice is 100, 171 degrees. This butt splice here, 113 degrees. And the overall wire temperature is 102 degrees Fahrenheit. So now let's say you get yourself in a QSO. So we'll say now on the key and off the key. And you wait for your buddy to respond. then you fire down. Then you unkey. Then your buddy talks back to you for a couple seconds. Then you fire down again. Okay, and then you unkey again. So we've just keyed down like 4 or 5 times in a row, which is nothing for a normal conversation, right? So and then you unkey again. So 5 times fired down gets us 184 degrees on that. 121 degrees here. And the wire's 115. Okay. What are we learning from the moral of the story of this? These butt splices are like giant resistors, and they're inducing a lot more heat into the wire. Remember, now we're only 20 to, and this is within 5 key downs for only 3 to 4 seconds of fire down on the key at a time. This wire is too small. It is not the right gauge. On paper, it looks awesome. Now, here's the other variable to voltage sag. Your vehicle runs at 12.5 when it's off. The battery, you're running off a battery at 12.5. Your amplifier is designed to have 14 volts put in it, 12.5 to 14 volts put in it, roughly. Okay? If you are at 12 volts on the input, you're now at 10 volts at the amp. Two volts. So now you're at 10 volts. So guess what? The lower you go in voltage, the higher your amp draw. So now your amp draw is going to be around 200 amps. But look at your volt draw now. Now it's down to 8 volts if this was 12 volts going in. Well, that's just your standard key down time. I can physically see this wire flexing. And that's just from being at 12 volts. So now you have substantial sag. You're down to 8-9 volts inside the amplifier from using this size of wire on a 12 volt system with the car off. So you fire back down again. We'll say that this is at 12 volts. 10 volts. With 200 amps worth of draw. Because your amp draw is going to go up as your voltage goes down. So I'll unkey again. Now here, you know what? I'll shut the power supply off and we'll just go down and run on batteries here. This won't take long for us to get there. That butt splice is now 239 degrees. There's 225. Our power wire is now 145 degrees. Now we're at 14 volts. We're going to pretend like we just shut the key off on the vehicle and you're still sitting there talking on it. Put about 130 amps on it. And as your voltage drops, the amperage is going to increase. Look at the sag. The transistors on the inside of the amplifier are going to pull more and more current the lower that gets. So we're going to unkey again. We'll key it up again. 160. See, now we're down below 9 volts at 12.2. That's resting voltage. Lead acid batteries, guess what? The resting voltage is 12.5, but they're rated for cold crank. Well, guess what? Cold crank means that they only maintain the voltage to 11.9 volts or 11.5 volts. So, under load, that's theoretically a beautiful battery at 12 volts with 150 amps on it. You're feeding your equipment 9 volts. 9 volts worth of energy versus 14.5. We'll back this down again. We'll pull out of the carbon pile completely. So the only thing that's pulling current now is the fan. That's cooling the carbon pile and keeping it from melting down. Well, butt splices are 240 degrees. Our feed point over here at our amplifier, otherwise what would be our plug, is 150 degrees, roughly, on the ground side. And the wire temp itself, 160 degrees. If this insulation fails its UL listing and its CE rating at 221 degrees, at 160, 150, 160, we've already gone through half the wire's ability to insulate itself. And this is only half of your standard install distance. That's why I say you have to use bigger wire. So now we've sat for a couple minutes, and it's your turn back on the net again with your all band, all mode on 80 meters, making 700 watts Ameritron 4-pill amplifier. And you're going to put the full 75 or 100 watts in it. Let's get back up there. We'll pull about 120, 130 amps on it. Voltage just drops to the basement. Remember, these two numbers are tied together. The lower this goes, the more current this is going to pull. Is this an accurate, completely 100% factory grade carbon pile? No. So we'll keep backing this off. We'll keep it around 150. We'll back it all the way down to 100. It's still a remarkable amount of loss. Remarkable. Yeah, we've now well blown past the failure point of the wire here. See, the wire is sticky. Literally leaving my fingerprint on it. The jacket on the butt splices is now sticking to my fingers. I got leather for hands. That is hot to the touch by far. The point is proven. The point is proven. Okay, now let's have a little bit of fun with this. Can't even pull 500 amps with it. I'm going to put 500 amps worth of energy in to get 270 amps out. Wow, I can't believe this wire is just not bursting into flames. What's a poppin'? It's the reason alternators matter. Look at the voltage difference. Let's give the carbon pile a second to catch up. Let's get our voltage back up so we can push more current on it. Okay, long enough rest period for me. There's 300 amps. It's the most we're going to get out of it. 500 amps going in. Wire's starting to smoke, and I'm about ready to have a massive fire if I don't pull out of this. The reason I got to stop is because I don't want to reach down here and disconnect the wires with my bare fleshy meat beaters. That would hurt. I mean, the wire is smoking. Wire's 330 degrees now. All right, I have a massive fire, like a short. There it is. There it is. Yay, that's what I was looking for. The point is, you get the wire hot. You get the wire hot, and you're going to have a short, and your whole car is going to burn down to the ground. And it's going to keep burning, because remember, the copper itself that makes up the wire, the copper itself isn't going to stop until the copper goes liquid, and then it breaks because of gravity. So until you disconnect your battery, this fire isn't going to stop, and it's going to catch the carpet and the liner and the floorboard and firewall and all the other wires around it on fire as well. Use bigger wire, use real grommets, use real connectors. Don't mess around. Okay, my point's proven. This wire isn't big enough to carry the load, obviously. We had way too much voltage sag going on. Double the amount of amps going in versus what's getting pulled. That means the wire's got too high of electrical resistance, and you're beating the shit out of your components. I mean, literally beating the shit out of your transistors. Use bigger wire. Use bigger wire. Use bigger wire. Gentlemen, okay, on a serious note, yes, I took this to 3 times the amount of current load that this wire would ever see. I get that. It doesn't invalidate the point that this wire is too small. In the DC world, I don't care if it's car audio, I don't care if it's amplifiers, HF, VHF, whatever, I don't care, however you move a DC around, you want to minimize your amount of voltage drop. We all know the difference, especially in the radio world, my guys. The difference in power out potential and the amount of heat generated by the component, like how hot your amplifier gets between 12 volts and 14 volts. It's dramatic, the difference. So if you're using substandard wire that is too small with substandard connectors, okay, and substandard plugs, you are running the risk of your entire vehicle, which is obvious. I'd think that would be obvious. Use bigger wire. 3 strands of 10 would have been appropriate in my opinion. Not 2. And he probably, if this would have been just the stock wire length, which we all know is never enough to make it work, and this is only half of what you would consider to be an actual install distance. I mean, from the battery to run a piece of 4 gauge. Run a piece of 4 gauge. For 100 amps, run 4 gauge. Well, the wire chart says yes, but your voltage drop is so much. The idea is to keep the voltage up. You want to keep the voltage up. And people forget about that. So when they call and they tell me, oh, I built the system for that, and blah, 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 and it was perfect. And then I get it on this end and it's overheated and everything's burned up on the inside. I'm like, no, it wasn't perfect. It wasn't. Please. Overrate your fuses, overrate your breakers, put big eyelets, crimp, solder the eyelets on the 12 volt side. I don't care. The debaters can talk till the end of time. Please note that eyelet isn't deformed. This eyelet is not deformed or melted. These compression fittings with the magical cold weld, melted. 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 I might not explain it in every single video, but there's usually a reason behind why I do everything that I do. And it's really honestly to help promote the guys' ideas in their brains to use bigger wire. Use bigger wire. And pressure fittings suck. Crimp solder. Save your equipment. It's just like spay and neuter your animals. I'm Bob Barker, and this is The Price is Right. All right, I got to run. Thanks, guys. I'll see you. Click, click.